So we have this quadratic formula, which lets us find, in a nice way, all of the solutions to a quadratic equation, if it has any. To use the quadratic formula, we just need to write our equation in standard form, so multiply it out with 0 on one side. And in standard form, then, we can read off the numbers a, b, and c and throw them into the formula. Once we've thrown them into the formula, it's just a matter of working out the arithmetic. So we can get a simplified fraction of square roots, or we can get a decimal approximation, whichever one happens to be best for whatever we're trying to do. So in math class, typically it'll just be whichever one the instructions say we should do. So to solve a quadratic equation using the quadratic formula, we just get standard form, find a, b, and c, throw them into the formula. Here's what that looks like in an example. We're going to solve the equation 5x squared minus 8x plus 4 equals 10. So I'm going to start out just copying that equation. I notice that this is not in standard form. This number here is not 0. So I'll start by subtracting 10 from both sides. So 5x squared minus 8x. 4 minus 10 is negative 6, so minus 6 equals 0. A is 5, B is negative 8, C is negative 6. And I want to throw those into the quadratic formula, which I'm just going to write down here for reference. X equals the opposite of B plus or minus the square root b squared minus 4ac all over 2a. So when we plug in, we get x equals the opposite of negative 8 plus or minus the square root of negative 8 squared minus 4 times 5 times negative 6 all over 2 times 5. Okay, so here we have the solutions to our equation, but we can at least do some of this arithmetic. The opposite of negative 8 is a positive 8. Plus or minus. The stuff inside the square root, I'm just going to throw into the calculator. We have the square root of 184. And in the denominator, 2 times 5 all over 10. Now, why didn't I throw all of that into the calculator at once? Well, it's a little bit error prone, and also I suspect that 184 is not a perfect square. Throwing the square root of 184 into the calculator, I get that the square root of 184 is about 13.56. Since I want exact solutions, I don't want to use that decimal approximation. But I do want to see if I can simplify. So what does that mean? Well, first I want to see if I can simplify the square root. And probably I'm going to want to use a list of perfect squares on my calculator. So I'm going to hit y equals. I'm going to say x squared for y1. And then I'm going to say 184 divided by x squared for y2. And I'm going to look at my table. So I see that 2 squared, which is 4. So I see that 4 is a perfect square factor of 184. And then continuing down, I see I get all the way up to 10. 184 divided by 10 is less than 2. And the only place where I got a whole number for 184 divided by my perfect square is in this row. So I'm going to say the square root of 184 is the square root of 4 times 46. So that's the square root of 4 times the square root of 46, which is 2 times the square root of 46. So we can simplify this by simplifying that radical. We'll have 8 plus or minus 2 times the square root of 46 over 10. But now I see that 2 is a common factor in the numerator. 2 is also a factor of 10. So I can say that this is going to be 2 times 4 plus or minus root 46 over 2 times 5. Cancel out the 2's. And I'm left with, my solutions are x is 4 plus root 46 all over 5, and 4 minus root 46 all over 5. And those are perfectly good numbers, right? I can just leave those as my solutions. These two values of x are the solutions to my given quadratic equation.